Good morning, dear students, and welcome back to Vista's e-learning and online educational platform. My name is Denzil, your physics tutor for class 11. Let's get started with our session for today. Our discussion will be based on vectors. This is actually a bridge course to connect you from a high school level to your PU level or your CBSE 11th standard. This is actually a session 1 of the topic vector. Now, one thing that we have learnt in the previous few sessions is how to categorize a given physical quantity under the two called scalars and vectors. We defined scalars as those physical quantity which have magnitude but no direction. Vectors, on the other hand, have both magnitude and direction. So let's make a quick note of what a vector is. Vector are those physical quantity which consist of both magnitude and direction. So vector are physical quantities, so I'll just put QTY in abbreviated form, quantity which contains both magnitude meaning the value, and direction. We discussed a couple of examples for this. Now, these examples that we learned from the previous session, those physical quantities were displacement, velocity, and acceleration. Displacement, velocity, and acceleration. Now, for your insight, there are many more physical quantities that come under vectors. But so far, from the previous session, we've discussed three particular physical quantities, such as these three that are mentioned here. But now let's get to the depth of understanding a vector. So now we learn how to represent a vector. Vector representation. Usually, vectors are represented by a straight line with an arrow overhead. The arrow part of this vector is called head. It's called the head of a vector. And the other end part is what is called as the tail of the vector. So you have a head and a tail. This vector can be named by, let's call it A and B. So AB represents the vector. So you can write it. So let me move here. You can write it AB, which represent the vector, but this is incomplete representation of a vector. When you name a vector, remember what we have to do? Draw an arrow overhead. So this completely defines that AB is a vector. Now that we know how to denote a vector, how do we identify the magnitude and the direction of this vector? One way of obtaining that information is by identifying the length of the arrow. Once you can find the length of the arrow, it tells you what is the magnitude of the vector. So the length of the arrow tells you the magnitude of the vector. The direction that it is pointing at, the arrow that it is pointing at shows you in which direction. So this is one way how you can identify the magnitude and direction of the vector. What is the other method that we can identify the magnitude and the direction? The other manner is by using magnitude and direction. The other manner is by using a graphical method. So for this, I have a graph sheet that is already prepared. Now for this graph sheet, I will represent my set of x-axis, my representation of x-axis and the y-axis. So go ahead and plot it with me. Draw y-axis and the x-axis. The two reference axes, which are called ordinate and abscissa. Good enough? Yes. Suppose an object which starts from point O displaces to some point which is, let's say here, call it P. A vector which defines the position, that is from O to P. We will look into this, a vector which shows the position of an object. This is a vector. Obviously, why is a vector? Because it has a straight line with an arrow overhead. So it's a vector which defines or shows the position of the object. So the type of vector, we will discuss that in the next section. But first, let us identify the magnitude of this vector. Suppose the projection, by creating a projection along the x-axis from that position P, has √3 units along the x-axis and 1 unit along the y-axis. How do we identify in this case what would be the length of OP vector? The length, remember, the length of OP vector is nothing but the magnitude of the vector. So OP vector, to find its magnitude first of all is represented by this 2 bar, okay, which you might have also learned as modulus. You might call it modulus in mathematics. Why do you use a modulus? To eliminate some of the signs such as your positive and negative. But in this case, we eliminate the direction. A vector ordinarily has a magnitude and a direction, but when you put the 2 bars beside it, you're only determining its magnitude. You can put an arrow overhead or you could just write OP, which is also fine. Now, how would you find the length of OP? This is quite simple. First, you observe there's a triangle here, a right angle triangle. 2 sides are √3 and 1. How is this side 1? That's because it has the same length. Okay? So this side is also 1. Can you identify what is OP? Certainly. Why not? Find it by using Pythagoras' theorem. So you can write OP square, which is equals to √3 square plus 1 square. So can you identify what is OP? Go ahead, try it by yourself and you'll notice OP will be equals to 2 units. See, we've just determined the magnitude of a vector using a graphical method. Now, what about its direction? Now, in the last session, we learned the one method of finding the direction of a given physical quantity such as displacement, velocity, or acceleration is by denoting it with signs, positive and negative. Positive showing forward direction, negative showing backward direction. Positive for an upward direction, negative for a downward direction. But in this case, We cannot just assign or give a sign. So what would be the other method of determining a direction in a graph? In a graph, especially when there are two axes. Last session, only one axis. Motion in a straight line. So just one number line. But here you have two mutually perpendicular number lines. So how would you find direction in this case? Use a compass. Well, compass is very limited. All you have is north, south, east, west, northeast or northeast, southwest, and so on. But you do not have, so you have almost 1, 2, 3, 4, 5, 6, 7, 8 such direction that can be shown. But this is not exactly pointing at northeast. So what would be an alternative method, a precise manner in how you can find the direction of this vector? It is by using angle. So you identify the angle this vector makes with respect to x-axis. See, the other way of identifying a direction, which is by using angle. So now you have learned three different methods of identifying a direction for a vector. One is with the sign, plus or minus. Second is by using a compass. And third is now using an angle in a graph. So now we have to identify what is this angle. So how do we identify the angle? Well, we go back to our lower standards where you might have learned trigonometry ratios. The trigonometry ratios, and some of you trigonometry ratios you might have learned are those sine, cosine, tangent, right? So let us try to apply one of the trigonometry ratio. First, we need to identify the sides of a trigonometry ratio. Okay, we need to identify the sides of a triangle. Which one is opposite, which one is adjacent, and which one is hypotenuse. You might have learnt it the other manner, such as height, base, and hypotenuse. Okay, so height, I call it opposite, base, I call it adjacent, and hypotenuse is hypotenuse. So how do we identify? I'll teach you by two simple rules. Okay, now for those of you who have difficulty in understanding trigonometry ratios, I've already conducted a bridge course for trigonometry ratios. You can look back and then try to recollect the things from there, and you can attend this session where we deal with some of those trigonometry ratios. All right, so in this case, two simple rules that I'll teach you. One is how to identify opposite and adjacent. Two is how to identify the hypotenuse. Let's pick the latter first. When you have a line, when the two meet and creates a perpendicular, that is when the two are mutually perpendicular to each other, the third line is always the hypotenuse. All right. So two mutually perpendicular line, apart from that two mutually perpendicular line, the third line is always the hypotenuse. Rule number 2. Identify the angle where it is located. Now you don't have to worry about hypotenuse. So first, now identify the angle where it is located. The line that is opposite to this angle, which is that line, this line here, is opposite to the angle, and hence opposite side. And the line that is beside the angle is called adjacent side. Now we know the value for opposite, we know the value for adjacent. So opposite divided by adjacent. What trigonometry ratio has this opposite by adjacent? You define it by tan theta. What is the opposite value? 1. What is the adjacent value? √3. So now you have to find theta, which means you take tan inverse of 1 by root 3. And what is tan inverse of 1 by root 3? If you follow the standard angles, again, visit www.v-learning.in. There you see under the bridge course, trigonometry ratios, I've taught you how to identify some of the standard angles, a shortcut method. Okay. There you will see the angle that it relates to is theta equals to, okay, let me write here, theta equals to 30 degrees. So tan inverse of 1 by root 3 is 30 degrees. So this is how you find the magnitude and direction using a graphical method. Now moving on to types of vectors. The first type of vector is a zero vector. Zero vectors are those whose magnitude is 0. Simple. If a magnitude of a given vector is 0, then it is called a zero vector. Next, unit vector. Unit vector has a magnitude which is equals to 1 or unity. Unit. So how do we find this unit vector, and how do we represent it? Zero vector, we do not represent it, so we just ignore. But in case of unit vector, how do we represent it? Unit vector is also important because when it comes to dealing graphical method, we need to calculate it we need to find or plot under certain bases, which we'll be discussing soon. These bases deal with unit vector. So unit vector, let's say for an x-axis, along the x-axis are usually represented with an x cap. X, and this hat, what you see overhead, is called a cap or x hat. You can call it cap or a hat. Both mean the same. So x cap or x hat. Now how do we determine this unit vector? First, you take the x vector and you divide that by the magnitude of x vector. And in the previous example, we calculated for an OP vector, so OP cap, which is equals to OP vector divided by magnitude of OP. Now, as you see, there are too many letters under a cap, so you can represent it with a single letter. In fact, if I go back, this OP can be represented using a single letter. How? Just put an R. Okay. Define this OP vector, which is equals to R vector, and things will be simplified for you. All right. Next, position vector. Now remember in the previous section where we defined the position of a given vector from O to P. So position vector is defined as the vector that denotes the position of an object from an origin. Okay, so if this is origin O to a position P, then this vector, which is drawn from O to P, is defined as your position vector. Co-initial vectors. Co-initial vectors are those where two or more vectors have the same starting point. So let's say OP is one such, and then you have OQ. You see, there are two vectors which have the same starting point. These type of vectors are called co-initial vectors. Next, like vectors and unlike vectors. If two or more vectors are pointing along the same direction, one vector that is AB pointing along this direction. There's also another vector CD pointing along the same direction. If they're pointing along the same direction, then these type of vectors are called like vectors. Now on the other hand, if one of the vectors is pointing in the opposite direction, then the vector is called unlike vector. So like vector and unlike vector. Collinear vector. Collinear vectors are those when one vector lies on another vector. Alright, what does that really mean? So if you have one vector, let's say PQ, above which you have another vector lying on top of it, AB. So represented by two different colors, alright? PQ is one vector, AB is another vector, but they're lying on one top of another. These type of vectors are what are called as collinear vector. Alright? So I'll erase this. Next, equal vector. If two vectors have same magnitude, okay, same magnitude, then it is said to be equal vectors. Same magnitude pointing along the same direction, they're called equal vectors. Displacement vector. Displacement vector, vectors which tells you which is defined as a vector that tells you the displacement of an object. So how much an object has displaced from its initial position. And then finally, negative of a vector. Vectors can be positive, negative because of their direction. So vector one pointing along a positive direction, another pointing along the negative direction. So you can take a vector which is pointing along a positive direction, let's say AB, and then you can flip this vector, and when you flip this vector in the opposite direction, it changes by a sign, which is negative. So these are the various types of vectors. And now we learn a little more about this base vector. So I hope you've understood what is a unit vector. We'll get to later in determining a unit vector, how to determine a unit vector by a given example. As a definition I've provided to you, which is of this sort. Alright, but as an example we shall see that later. Base vector. So using a set of coordinates as your x-axis and y-axis, to these two respective coordinates you break those into parts, and each part has a certain unit. A certain unit means certain value. So this value, the values that you represent along the x-axis and the y-axis, the smallest value that you represent it with is what is called as your base vector. So let's take an example in this case where you have your y-axis that is defined, and then you have your x-axis. All right. Now, the smallest unit that I can define in this case, starting from here. So each unit is based on a base vector. So if the unit, let's say, starting from 0, and then you start with 1, and you add plus 1, so it becomes 2, and plus 1 3, plus 1 4. So your base vector in this along the x-axis would be 1. Similarly, along the y-axis, you can mention what are the respective base vectors. So let me go on writing this 7, 8, 9. I'll complete this one as well. 2, 3, 4, 5, 6, 7, 8, and 9. Okay. Now let's suppose an object displaces from origin to position 3 along the x-axis. Not bad. Okay, so you have one vector which is along the position 3. From position 3, it displaces 4 units along the y-axis. Alright, from position 3 along x-axis, 4 units along the y-axis. Alright. What is the new position of an object? So here we're dealing with the position vector from origin. So what is the new position meaning? What is the displacement of the object from the origin? Now remember displacement. Displacement is the shortest distance between the 2 points, initial and the final. Initial point is the origin, final point is this point where it is located. Shortest distance is represented using a what type of line? Curved line or a straight line? Shortest distance. Think about it. Shortest distance. Is it a curved line or a straight line? Shortest distance must be a straight line. So this new vector that I've constructed is the type of vector is a position vector. We'll represent it by the letter R. Okay. Now, how do I define this vector R with respect to x-axis and with respect to y-axis? So when I write it down, all the information such as its magnitude and direction must also be noted down. Because when you write things down about its magnitude and direction in a short and sweet manner, you do not need a graph paper. Or God forbid, I don't know how many graph paper you'll be using for every vector that you'll be drawing, right? So our vector, which is equals to 3 units along the x-axis and 4 units along the y-axis. 3 units along the x-axis plus the 4 units along the y-axis. Now I've just written the number, but I've not mentioned in which direction. This is along the x-axis, this is along the y-axis. To represent which direction, I introduce unit vectors, which are the base vectors for x-axis and y-axis. Base vectors for x-axis, so let me write that. Base vectors for x-axis are usually given by I cap, and for along the y-axis it is usually denoted with a j cap. This is only for a 2-dimensional plane, but if it's for a 3-dimensional, that is when you have x, y and z axis, that is the 2 plane of the board, x-axis and y-axis, and then there's one more axis which is pointing in an outward direction. So in that case, the base vector would be k cap. I cap, j cap and k cap. So I can denote these the position along the x-axis and y-axis with respect to its base vectors as I cap and j cap. This is a formal definition of a vector, which you could call it as a Euclidean definition of a vector as well. Okay, there's another word for it, a Euclidean definition of a vector, where R vector equals to 3I cap plus 4j cap. How is that I can calculate the magnitude and direction? Not to worry. I'll show you how to calculate the magnitude and direction. Usually a vector like this, when it is given, let's say a I cap plus bj cap. So this is just an example. Okay, I'm just doing an example. To find the magnitude of a vector, it is equals to square root of a square plus b square. This is how you find the magnitude. Similarly, to find the direction, it is always b by a. b by a. Okay? So, can we apply the same concept here? Yes, we can. You know what is the a value. You know what is the b value. Now, can you find the magnitude of r vector? Go ahead, try it by yourself. There's no space, no space. Do I have it in the next page? Okay. So, make note of this. We will anyways calculate the magnitude. Make note of this first. Okay. I hope you've done. So now we erase this. All right. And now we find the magnitude of the vector. Magnitude of r vector, which is equals to square root of 3 square plus 4 square. And square root of 3 square is 9, 4 square is 16, 9 plus 16 is 25. Square root of 25 is 5 units. You see, we have just determined the magnitude of a vector using the following data, not even by a graphical method. All right. Now, similarly, the direction. Direction of a vector, where tan theta is equals to b by a, 4 by 3. So tan inverse of 4 by 3, theta equals to tan inverse of 4 by 3. You get a certain value for this. Not to worry about it. You get a certain degree, an angle, by tan inverse of 4 by 3. Okay, so this is how you find the magnitude and direction by using the information of a base vector. All right. Now moving ahead, some of the operations of vector. When it comes to two or more vectors give rise to an additional vector. An example, let me give you an example. Let's say a box is being pushed or pulled. Let's say pulled in this case. You have two people who try to pull the box. So one person is holding onto the box and pulling it along this direction here. You have another person who is holding the box by a thread, and then he pulls it along with this direction. Okay, so it is not horizontal, it is somewhat inclined. Which direction will the box move? Will it move towards person A or person B? Which direction will the box move? Towards A or towards B? It will not move towards A, it will not move towards B, rather it moves in between the two. So two vectors, one vector, because force is a vector quantity, which we will learn eventually. One vector pointing along that direction, another vector pointing along this direction, gives rise to a third vector. So you see that two vectors can be added to give rise to a third vector, and hence some of the operations on vector such as addition. There are a couple of rules of addition. There are two such rules of addition. One is called a triangle law of addition. In case of a triangle law of addition, it says that when one vector, okay, let's say P vector, when one vector P vector is combined with another vector such a way that the tail of the second vector coincides with the head of the first vector. I'll repeat one more time. One vector P vector and a second vector Q vector. Q vector is drawn such a manner that the tail of the Q vector coincides with the head of the P vector. If such vectors are represented, this gives rise to a third vector. The third vector is drawn in such a manner that it starts from the tail of the first vector and coincides with the head of the second vector. So this is by combining the two vectors P vector plus Q vector, which gives rise to a third vector. Such a way the tail of the third vector coincides with the tail of the first vector. Head of the third vector coincides with the head of the first vector. This third vector are what are usually termed as a resultant vector. Okay, it is also called resultant vector. Final vector you can also call final vector or resultant vector. Quite simple when two vectors are added. Yes? Now, how can we add two vectors when you consider base vectors? Now remember those base vectors we discussed, r vector equals to 3i cap plus 4j cap. Yes. How will you add when you have two different base vectors that are given, or two vectors represented by the base vector? Let's say one vector P vector, which is equals to a1i cap plus b1j cap, and Q vector is defined as a2i cap plus b2j cap. What happens when you add these two vectors? When you have P vector plus Q vector, which is equals to, you add these two vectors, a1i cap plus b1j cap plus, I keep running out of spaces, man. You know something about this, hey? Don't you think so? I keep running out of spaces. All right. And then a2i cap plus b2j cap. Since you're adding, a1, a2 have the same base vector or unit vectors I cap. b1, b2 have the same unit vector j cap. So you can put this under a common term where P vector plus Q vector, which is equals to a1 plus a2 I cap plus b1 plus b2 j cap. Easy. So shall we see this by an example? P vector, let's say, is 3i cap plus 4j cap, and Q vector is 4i cap plus 2j cap. So what will be P vector plus Q vector? Use the final form, a1 plus a2, 3 plus 4, plus b1 plus b2, 4 plus 2. See? You've added the two vectors, P vector and Q vector. Can you find the magnitude? Why not? Certainly you can find the magnitude. In the previous case, we found the magnitude and direction. So you can find the magnitude and direction for this P vector plus Q vector. I think I'll stop here. There are more, in fact, where we learn about addition by using a parallelogram law of addition, subtraction, multiplication, which is of dot product and cross product. So we will discuss these problems or the concepts in the next session. But do visit us at www.we-learning.in to get a recap of previous bridge courses, where I've conducted bridge courses for trigonometry, for calculus, differential calculus. But sooner or later, I'll also be conducting a bridge course for integral calculus. Okay, so now that we have started with vectors, we'll finish vectors and then I'll start a bridge course for integral calculus. So until then, I wish you all a nice day. Take care, everyone, and bye bye.